Hello, my name is Caleb Jones. I will be demonstrating how to set up quality of service techniques using Cisco Packet Tracer. During the demonstration, I will be explaining how each step of implementing quality service techniques is done, why it is done, and what will occur if implemented correctly. Before starting the demonstration in Packet Tracer, I would like to explain what QoS is and the various reasons on why we do it. So, QoS, it stands for quality of service. It is the techniques or methods that are used to filter various types of traffic on a network. And within these traffic, they have measurements for it. Bandwidth, which is the speed of a link, which could be an interface on a router or switch. We got delay, which is the time it takes for a packet to go from its source to the end destination where it needs to be. Then there's loss, the amount of data lost as a result of packet loss, which occurs due to network congestion, and we will get into the causes of network congestion later in this PowerPoint. And then there's jitter, which is just an irregular speed of packets on a network, which is also a result of congestion. Which, with jitter, packets can arrive late or out of sequence, which will affect audio and video. So, what are some examples of QoS? There's queuing. Queuing is the process of creating policies that give preferential treatment to certain types of packets or data streams over other ones. With queuing, we would want to prioritize video and audio packets over just strictly data packets because of the bandwidth that that video and audio packets need. Then we have resource reservation, which could also be resource reservation protocol, which reserves resources across a network to allow different levels of quality of service for different applications that need more bandwidth than others. Again, an example would be video streams and video and audio streams, like something like Zoom would be, getting preferential treatment and more resources compared to just email and other just strictly data packets. And they got prioritization of sensitive data still being voice traffic over routers and switches. So when the routers and switches start getting congestion, they will start dropping packets. So we need to use this prioritization to determine which packets will be dropped first, which would be data packets, which can stand to lose a few packets compared to audio and video packets. So why do we implement quality of service? There are several reasons that can be seen here. One is to just control your network traffic, and with controlling the traffic, you ensure that critical applications will perform properly as mentioned prior, because they will get the proper amount of bandwidth they need in order to function properly and not be jittery or lose frames that are crucial to do their job. The last reason to implement quality of service is just to ensure that your network speed and efficiency is the most optimal it can get to not affect other parts of your network. So what will happen if you don't implement quality of service? Well, the network will experience congestion due to the amount of packets trying to go in and out of the network. High level of package will mean congestion, which will lead to packet drops, as mentioned prior. With packet drops, if it's crucial data, then that data is gone and will affect the rest of the data sent over, and it will be incomplete. The second thing that will occur not implementing is just your network will become disorganized. The performance will suffer across the network, and it could shut down your network completely if left unmanaged. The last point goes along with the second one. The performance of your network will become less reliable. Less reliable networks means that you will not be able to properly send out emails, for example, and it could result bit more of the business part of your company, which you want to avoid. You want to have a good performing network that is reliable. There's also implementing QoS incorrectly. This can occur just from misconfigurations, incompatible software and hardware, and just abuse from attackers. It will lead to similar problems that you would get from not implementing it, so you need to be able to implement QoS correctly. Otherwise, you will run into network issues that are difficult to troubleshoot, and you can cause network outages by doing this incorrectly by trying to use more bandwidth than available, and you could shut down your network completely. So when you implement it properly, you will see a smooth performance of your network, and critical applications will perform better regardless of the capacity of your network or your network bandwidth. And you will see less or very, very little network congestion or packet loss with QoS being properly implemented. Now we can transition over to Packet Tracer to show how to set this up in a simple 3-tiered network. Okay, so here we are with our 3-tiered network. Pretty standard, just it has data and voice capabilities with RP phones and PCs respectively. So it should be noted that we are going to be working with 2811 routers and 3560 switches. These are layer 3 switches that will allow us to do more QoS techniques than their layer 2 counterparts. Especially with my experience with the version of Cisco, the layer 2 switches they have available for you to use do not allow very many features to be enabled. So to start, we're just going to go into one of the layer 3 switches. Hit enter and then go to the configure terminal, and from here we can check the status of quality of service on one of the interfaces by just typing show we need to go down a level, and then from here we'll go show MLS QoS. We type in the interface, fast Ethernet, and then for this case all of our PCs are on 0.1 and all of our phones are on 0.2. So we can check either one. I'm just going to type in 0.1 and then hit enter. And from here we get the information about QoS on this interface. And as you can see, it is not enabled at the moment. So to do anything, we need to first enable QoS on the switch. To do that, we go into the configured terminal. And then from here, just type in MLS QoS. And now our switch has quality of service enabled. From here, we need to make some access lists. We're going to be using this to mark traffic on this network to set precedence on what should be dropped first. So let's start with the access list. I'm just going to create access list 110, and it's going to be permit UDP for our voice traffic, and then any for the network address, EQ, which is the port they're going to specify only, and this port is 2000. Hit enter, and then we're going to create 2 more access lists regarding ping or IMCMP. And then it's going to be a completely different access list, so we're going to do access list 120 permit TMCP or TCP. Excuse me again. IMCP. That was right the first time. And then any, and for the last part, we're going to type in echo. And then the second part of this, it's going to be access list 120 as well. Permit IMCP, any, echo replies. Hit enter. Okay, with those created, now we can make our class map. So all you need to do is in the configure tab, type in class map, and then name it whatever fits here. So since this involves VoIP and IMCP, we're going to type in for one of them VoIP, and then hit enter, and now you're inside the class map. From here, we can set it to match with the group we created. So match, and then it'll be access group 110, and then you hit enter, and you can exit out of this. And then we do the same thing for another one, which is class map, and then ICMP. And this one will be match access group 120. Now, with our class maps created, we can create a policy map, and it's created in a similar sense to class maps. Oops. So from the configure tab, type in policy map, and then name it whatever. So we'll name it precedent, and then hit enter, and then enter the classes that we have. So class VoIP, and we can set that to a higher level of precedence, because the higher the level of precedence set, the higher priority these packets will get. So we can just set it to IP precedent. Nope. Five. Oops. Hold on. No. Sorry. I just gotta set this first. Apologies, I misspoke. So the command here is set just precedent with no IP, and then the level of priority that you want this to have. It ranges. We can look at the levels by just typing in question mark, and we can determine what level of priority these packets need. It goes from 0 to 7, 0 being the lowest, 7 being the highest. And we're going to just set the voice packets at precedent 5 for critical. If we have to choose between packets being sent, these are the more critical packets, because it will mess with the whole message if we lose any of these packets. And then after that, we can just hit enter, and that's set. Once again, we just exit out of this. We're still in the policy map. We just we have to configure our other class map. So class, and then class ICMP. and then we're just going to leave these packets, set the packet precedence for these at just 0, because they only have 2 types of packets. So one can be critical, and these will just be routine. Well, we'll just raise it up to priority, so some packets will be sent if we add another type of traffic and we decide that our ICMP packets need more precedent over them. They'll have a priority above them. Just hit enter again, and we're good to exit out of the policy map. And we just need to configure the interfaces on which this will be affected on. So it'll be interface range, and it'll fast Ethernet 0, 1, and 2. And now we just type in service policy and input and the name of the policy map we have. So it's precedence. Okay, with that set up here, we can go back and check and make sure everything was properly set just by running command outside of the config tab with a show MLS QoS interface fast Ethernet, and we just check on both of them individually. Oh, my apologies. So we really need to check and make sure that what we set up did take effect. So we need to show class map, and we can see both of our maps set up here, and we can check our policy map. Oops. And see that both classes are there with the precedence set where they need to be. So from here, with that part done, we're going to move on to a different type of QoS. We're going to implement policy at the router level. So we're going to be doing this using class maps again. So we're going to go to this middle router because we've already messed with this network, and we're just going to enter it. And go into the config tab. And then let's just say we want to, again, limit how many pings we can receive on the router, or if we can receive from one of our PCs. So we're just going to name it, again, ICMP. And then we're going to match the protocol to IMCP. With this, we can now create a policy map. So we exit the class map, and then once again create a policy map. And we'll just name this policy map just policing. And we'll apply our class to it. And we can look through our list of things here and see what we want to do. I apologize. This is not please. This is shaping. You can see from the command at the very bottom. We're going to type in shape. And we'll just type in average. And what it looks for next is a bit rate between 8,000 bits and it looks for an average set of bits we can set. So we can just either put the bit rate at, let's just do 3200 bits. And then after this, we need to exit this and apply it to our interface. It's going to be on. So we need to exit all the way down to the config and then go into interface fast Ethernet 00.10. No, just fast Ethernet 00. And apply the service policy. And then the name of our class map, which is IMCP. Or sorry, it's policing. And then after that, just hit enter. And that's how you apply the shaping to a network. So that done, really, those are the two things that you can do within Packet Tracer that I've seen that's not really limited. There are other steps, there are other quality service things that can be done to other forms of equipment with different types of routers, switches, and when you get to work with physical equipment, there'll be you can use this if you're working with 3560s or 2811s, but that covers most of quality of service that you can, the basics of quality of service that you can implement within Packet Tracer.